Hey everybody, we've been talking about graphing linear equations, and I just wanted to go over a few things with you guys and review what graphing linear equations looks like. So if you look at this first problem, it says graph the line y equals negative 4/3 x plus 5. Now this line is in slope-intercept form. So if it's in slope-intercept form, this makes it really easy for us to graph it. So the first thing I'm going to do is I'm going to determine what my y-intercept is. And my y-intercept is always the number, when this equation is solved for y, it is the number that is without the x, and it's typically on the back end. So positive 5 would be my y-intercept, or my b. So if I go to my graph and I go to where this line is going to cross the y-axis at 5. The point is 0, 5. So I can put a point here at 0, 5. Now I need to determine what my slope is. Well, my slope is the number in front of x, because we're using slope-intercept form, which is y equals mx plus b, and m is my slope. So negative 4/3 is going to be my slope. So m equals negative 4/3. This means, remember, the top number is rise and the bottom number is run. So I can go down 4, 1, 2, 3, 4, and over 3, like this. Or I can go up 4 and back 3, like this. And I can do this all the way across the graph from one point to the next. So I will keep doing that until my line is all the way across the graph. And I'm going to connect my points using a line. Now please remember, when you draw your line, to make sure that you use arrows on the end of this line. Because when we talk about these problems in context, arrows mean a lot. It talks about constraints and the limits of our problem. But right here, any solution that's on this line, it goes on forever, will satisfy the equation. So this is you graphing a line. Okay, I want you on your own paper to try this. Graph the line y equals 6x minus 5. Make sure you know what the y-intercept is and what the slope is. And make sure your line is going in the correct direction. On the last one I had a negative slope, so it was going in a downward direction. So make sure that you know which direction your line needs to go. Try that out right now. Alright, so here's what I got. I got that the slope was that the y-intercept is negative 5, and that the slope was 6. So here we had a slope that was a whole number. So when we deal with that slope, remember that the 6 is technically our rise, and that our denominator here would be 1. So that means our run is 1. So if you look at the graph over here, you'll see that I started at a y-intercept of negative 5, and I rose 6, and I ran 1. And it should form a right triangle each time I rise and I run. Now the other key thing here is my slope here was positive. So when I look from left to right, my line is going in an upward direction. We've talked about running man in our class, and remember, I like to draw running man over on the left hand side, and I like to see, okay, is running man going uphill or down here? Hill. Here he's going uphill, so that's great. That tells me that I graphed it properly and that the slope is positive. Now this is a context situation, this next problem, and it's talking about how much a guy's weekly earnings are. So Matthew receives a base weekly salary of $300 plus a commission of $50 for each vacuum he sells. What is the equation that models his weekly earnings? Graph this equation. So we have a two-part thing that we need to do here. We need to write an equation, because it says what is the equation, and we also need to graph it. Well, they gave us enough information in order for us to do both of those things. So if we look back at the problem, we're talking about Matthew, and his base salary for the week is $300 plus a commission of $50 for each vacuum he sells. So what does he start out with? He starts, every week he's going to make $300, right? And then from there, once he makes that $300, every vacuum that he sells, he's going to get $50 additionally on top of that. So it's $50 per vacuum. Keeping that in mind, which one of these do you think is going to be your y-intercept? If you said that the $300 is the y-intercept, you're correct, because that's what he starts with. Remember, B is where we begin. It's where we start. It's our initial value. So the initial value that he has is $300. And then his slope would be the $50 because each vacuum he sells is going to increase his pay by $50. So the $50 would be his slope. So my equation here, remember I still have to write an equation, would be y equals, M is $50, and so 50x plus 300. Alright, so the next thing here that seems to typically be a hard thing for us to do is to figure out how in the world we want to number this graph to satisfy our needs. So thinking on that, how we want to use this graph to meet our needs, we need to figure out how we're going to number it. Well, count and see how many units are on each side, how many divisions we have, so that we can figure out what our increments need to be. Do that right now. Okay, I figured out that this is 15 units high and 15 units wide. That should have been what you got. So when I do this, it helps me to make a t-table to figure out what values I should begin with and how I should count on my graph. So if I start and I have that I sold no vacuums, and I use this equation that we've written, how much money would Matthew earn if he sold no vacuums? You should have gotten $300. But if he sells one vacuum, what will he get? $350. And if he sells 2 vacuums, he's going to get $400. What is the pattern here? What are each of these things increasing by? I would say they're increasing by 50 each time. So when I number my graph, my x's, I can number them by standard 1, 2, 3, 4, 5, 6, and begin with 0. But for my y's, it doesn't make very much sense if I start numbering them at 1, or at, I count by 20s, or something like that. It would make more sense to me if I counted by 50s. So when I number this, I'm going to start both of them at 0. So down here I'll have 0. And then I'm going to count by 50s on the y-axis, but then I'm going to count by 1s on the x-axis. So on the x-axis it would look like this: 1, 2, 3, 4, 5, and so on. Alright, and then here on the y-axis it would be 50, 100, 150, 200, 250, 300, 350, 400, and so on. So you go ahead and number your axes like you need them so that you can graph this. Okay, so when I numbered my graph, it looked something like this. It went up to 15 and up to 750 on the y-axis. So then I need to graph my actual line. So using what I know that when I have sold 0 vacuums, you have $300. But then when I sell 1 vacuum, my salary will increase to $350. If I sell 2, it'll be $400. So I'm rising 50 and I'm running 1 each time using my slope. Now, as I draw this line, I need to think about something. Do I need arrows on both ends of the line? Do I need them on one? Or do I need them at all? I need to think about my constraints. So here, am I going to make less than $300? Or am I guaranteed to make $300? You're guaranteed to make $300. That's right. So I'm not going to go below $300, so I don't need an arrow on this end of the line. That's not necessary because it's not going to happen. However, my graph here only shows that if I sell 9 vacuums, I will earn $750. So that means I could sell 10, 11, 12, I could sell 200 vacuums. So that means I need an arrow on this side of my line. But I don't need an arrow down on the bottom side. Now, also, my line is going in a positive direction, so it is going uphill. I've graphed everything correctly. All right, you're going to try this next one. Okay, so check your work against mine. I got that the slope was -8 because you're going to eat 8 pounds each day, so the weight of your food would be decreasing. And you start out with 70 pounds. So my y-intercept was 70. And then I set up my t-table to determine what my y values and x values needed to increase by. It made sense for my x values to increase by 1, but counted by 5s made more sense for my y values. Once I did that, though, I needed to look at, when am I going to run out of food? So what I did is I took this y value and I made it 0, and I worked the equation backwards to figure out what x would be when I had no more food. And after 8 3/4 days, or 8.75 days, I'd be out of food. So I grabbed those 4 points based on my numbering, and I came up with this line. Now, do I need arrows on each side of the line? I don't think I need them on either side because I'm not going to have more than 70 pounds of food, and I'm not going to have less than 0 pounds of food. And my pounds of food were represented by this axis, the y-axis, and my number of days were represented by the x-axis. So, please make sure that you can write an equation and graph it. And please make sure that you can graph an equation. If you're still having trouble with this, please come and talk to me.